Swayam Prabha. Digital India. Educated India.
Welcome back, learners. The video is for the subject of geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of climatology. We are discussing lecture 8 of module 3. The topic of the lecture is El Nino Southern Oscillation and Walker Circulation. We have already discussed part 1 of the lecture 8, and this particular video lecture is a continuation video lecture, and it is part 2 of video lecture 8, where we are discussing El Nino Southern Oscillations and Walker Cell. The video is being recorded by Dr. Pallavi Upreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM-PG Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayam Prabha Channels of MHRD, New Delhi, India. The learners will have a fair understanding of the ENSO phenomena after completing this particular video lecture. As we have already covered several important topics related to the ENSO phenomena in the previous lecture, which was M3L8 Part 1. And in this particular video lecture, which is M3L8 Part 2, we will be covering the remaining topics which are associated with the ENSO phenomena. So here we will be discussing the La Nina phase of the ENSO cycle and how La Nina phase impacts the weather conditions, and briefly we will also be discussing the impact of ENSO on monsoons in India. So this particular video lecture, that is M3L8 Part 2, is the continuation lecture of the M3L8 Part 1. So for better understanding, I request learners to go back and watch M3L8 Part 1 first and then come back and continue from here. So let's begin with the discussion on the La Nina phase of the ENSO cycle. Before starting this particular video lecture, I would like to give you a quick brief of what we did in the previous lecture, which is M3L8 Part 1. So we have already discussed the ENSO phenomena, and we have discussed that ENSO is cyclic in nature, which primarily have 3 phases. So out of the 3 phases in the previous video lecture, we have already discussed the 2 phases. The first one is the neutral phase, which is characterized by usual warm conditions in the Western Pacific Ocean and cooler conditions in the Eastern Pacific Ocean. And we have also discussed the warmer phase of the Pacific Ocean, which is the El Nino phase, wherein we have warmer than usual temperatures in the Central and Eastern Pacific Ocean. And today in this particular video lecture, we will be discussing the third phase of the ENSO cycle, which is the La Nina phase, which is the cooler phase of the ENSO cycle, and it is characterized by cooler than usual temperatures in the Central and Eastern Pacific Ocean. So ENSO phenomena is cyclic in nature, having these 3 primary phases, wherein generally the warmer phase is succeeded by the cooler phase, or vice versa, marked by the interim phase of neutral conditions in between. And then in the interim phase, you also have the neutral conditions. So it is cyclic in nature. Now let's just discuss what is the cooler phase of the ENSO cycle, or what is the La Nina phase of the ENSO cycle. La Nina, or the little girl, or simply a cold event, is the cyclic counterpart of the El Nino conditions, consisting of a cooling of surface waters of the Pacific Ocean along the western coast of South America. So the La Nina conditions are actually the extension of the neutral conditions only, wherein the trade winds which blow from east to west are unusually stronger. Because of these strong trade winds, you have more piling up of water along the western coast. So trade winds generally blow during the neutral conditions also from east to west, leading to piling up of water along the Asian side of the Pacific Ocean. But in the La Nina events, the trade winds become stronger than normal, causing increased accumulation along the western side and increased upwelling also along the eastern Pacific Ocean, because of which more cold water is being pushed further across the Pacific, causing anti-El Nino effect. So these are the neutral conditions, as you know, but during the La Nina phase, these neutral conditions are further intensified. Okay, and there is more piling up of water along the western Pacific coast, which further pushes the cold waters from below, leading to intensified upwelling also along the Peruvian or eastern Pacific coast. So such events are characterized by increased eastward pressure gradient over the equatorial Pacific, which is also called as high positive southern oscillation index, and stronger surface trade winds over the central Pacific, and below average sea surface temperature in the central and eastern tropical Pacific. So definitely when there is more piling up of water along the western Pacific, the pressure will be much lower along the Asian side, and there will be increased pressure gradient towards the South American side of the Pacific Ocean. And all this also intensifies the upwelling of the cold waters from below, leading to extremely low temperatures or lower than usual temperatures along the eastern Pacific and higher than usual temperatures along the western Pacific coast, intensifying the upwelling towards the eastern Pacific coast and intensifying the rainfall and precipitation conditions along the western Pacific coast or the Asian coast. So the La Nina conditions represents more intensified phase of the neutral conditions only. As you can see with the help of this particular animation, that how the neutral conditions exist in the Pacific Ocean, which are then intensified during the La Nina conditions. And you can see that during the neutral conditions, the trade winds are normally blowing over the Pacific Ocean. But you can see that as the trade winds intensify during the La Nina phase, there is more pushing up of water from the eastern side of the Pacific Ocean towards the western side of Pacific Ocean, intensifying all the atmospheric and oceanic phenomena which are associated with these conditions. So there is more upwelling of water along the western coast of South America, as you can see here, and then there is more piling up of water along the western side of the Pacific Ocean or towards the Asian side of Pacific Ocean. Because of all these oceanic changes, the related atmospheric conditions are also intensified. There is more rainfall along the Asian side and there is more dryness along the American side. There is more upwelling of water along the coast of Peru in this particular area. So basically during the La Nina conditions, the central and eastern Pacific Ocean becomes cooler than normal, and along the western side you have warmer than usual conditions because of more piling of water along the western Pacific side. So these are the La Nina conditions. So La Nina is nothing but the intensification of the already existing neutral conditions, and this is completely opposite of what we have seen in case of El Nino. La Nina events often follow El Nino events, and generally they may be separated by intermediate neutral conditions also, and generally it lasts between 1 to 3 years, unlike the El Nino events which usually last not more than a year or 8 to 9 months. peaking during the winter season. So La Nina events are generally more prolonged events and phenomena as compared to the El Nino events, and the tropical Pacific Ocean has been in constant state of La Nina since September 2020, with a short intermediary break during the June to August 2021 in between, and this La Nina situation is still continuing as of mid-November 2022, intensifying the low pressure systems along the Asian side and intensifying the high pressure systems along the American side, because of which the entire 2022 saw several events of floods in Pakistan and the Southeast and South Asian regions, whereas opposite to this you had drier conditions along the eastern coast of Pacific Ocean around Americas. And during this time period, the La Nina events threshold exceeded for both oceanic as well as atmospheric conditions. So definitely during the La Nina time period, the both atmospheric as well as the oceanic systems intensified, where you have intensified precipitation and rainfall conditions along the Asian side due to lower than usual pressure conditions which exist in these areas, and opposite to this you have higher than usual pressure that exists along the eastern coast of the Pacific Ocean, followed by low temperatures and drier than usual conditions. So definitely you will have more upwelling of cold waters along the eastern coast due to low temperature conditions which exist in these areas as compared to the western counterpart of the Pacific Ocean around the equator, which have higher than the usual temperature conditions. So as you can see that La Nina conditions are characterized by lower than usual temperatures along the Central and Eastern Pacific Ocean, whereas it has warmer than usual conditions which are experienced along the western coast of Pacific Ocean, and it is definitely opposite to the El Nino conditions, and it greatly impacts the oceanic as well as the related atmospheric conditions in the adjoining areas along both the coast of Pacific Ocean, specifically in the tropical areas. Now let's see how La Nina phase impact weather conditions around the world. La Nina events are associated with significant changes in the weather conditions, just like the El Nino conditions, since they are characterized by lower than normal air pressure over the western Pacific Ocean, and higher than usual temperatures are also experienced along the western Pacific Ocean. So these low pressure zones contribute to increased rainfall in the South Asian regions during the northern summers. So because of existing low pressure conditions and higher than usual temperatures, you have more intensively developed atmospheric systems in these areas, and the western coast of Pacific Ocean generally experience more extensively developed low pressure systems and increase in the rainfall conditions. So rainfall associated with the summer monsoon in Southeast Asia also tends to be greater than normal, especially around the northwestern India, Bangladesh, parts of Pakistan and the certain Southeast Asian nations. And it generally benefit the Indian economy to a greater extent, but sometimes because of very extensive rainfall, it may also cause massive flooding in these areas, creating disaster conditions. Although usually, because most of the Southeast Asian nations have agrarian systems which are monsoon dependent, so higher than usual monsoon is generally considered beneficial for the economies in the Southeast Asian region. However, because of very heavy precipitation, it may also lead to flood conditions, and conditions of disaster may also prevail in these areas. And recent 2022 floods in many Southeast Asian regions, especially Pakistan and certain areas of Southeast Asia, can be seen as how when the La Nina conditions become aggressive, it can lead to massive floods and disaster conditions also in these areas. So because of the triple dip La Nina effect that has been existing for the last 3 to 4 years, the rainfall conditions and the low pressure systems became so aggressive in these areas in 2022, witnessing floods in major parts of Southeast Asia and Asia. So La Nina events are also associated with rainier than normal conditions. So whenever the Western Pacific Ocean will experience the warming up phase, you will have rainier than normal conditions experienced over the Asia, and sometimes the impacts are also carried to even Southeastern Africa and northern Brazil region also. And during this intensifying phase, there is increased cyclonic activity also, because the low pressure systems which are found in the Western Pacific Ocean becomes very active, and there is intensifying of low pressure systems, increasing the cyclonic activity in the Western Pacific Ocean off the coast of Australia, Philippines, Southeast Asian region and the Western Atlantic region also. So primarily during the summer monsoon, most of the regions which are located along the western margins of Pacific Ocean witness heavy cyclonic activity, heavy precipitation conditions, and higher than normal precipitation and rainfall conditions exist in these areas. Whereas during this time period along the western coast of tropical America, drier than usual conditions exist, and you have continuous upwelling of cold water around the coast of Peru, and cooler than usual conditions exist around the Eastern Pacific Ocean. So La Nina conditions are also characterized by higher than normal pressure conditions over the central and Eastern Pacific Ocean, and these cold waters in the Pacific Ocean pushes the jet stream northward, leading to drought along the Eastern Pacific coast. Drier than normal conditions are observed along the western coast of tropical South America and the Gulf of United States. In this particular region, you have drier than usual conditions, whereas as the jet stream is pushed northward, the entire western coast of North America and certain parts of Canada also experience wetter conditions. So you have drought conditions along the southern regions of North America, Central America and certain parts of northern South America also, whereas you have wetter than usual conditions which exist in the northern limits of the North American continent around the western coast of Canada as well as the western coast of North America. Upwelling along the eastern Pacific coast support more marine life, hence good for the fishing industry of South America. So it is also true that due to more upwelling of cold waters along the eastern Pacific Ocean, you have better microenvironment which boosts the growth of fishes in these areas. Therefore, it is good for the fishing industry of South America during the La Nina phase. Generally, the La Nina phase is associated with more extensive and rainier than usual conditions around the Western Pacific Ocean or along the Asian side, and you have drier than usual conditions which are experienced along the Central and South American region, and you have upwelling along the Peru-Ecuador region of South America, and this upwelling is generally associated with better development of fishes and it supports the fishing industry of South America. Now let's just quickly see all the three phases of the ENSO cycle together, starting with the neutral phase. Under the neutral phase, you have east to west blowing trade winds which drag up the warm tropical Pacific Ocean water and pile up around the western side of the Pacific Ocean or towards the Asian side of the Pacific Ocean. So under the fully developed neutral conditions, you have piling up of warm water along the Asian side. Piling up of warm water causes the air to become warm and light, and it rises up causing precipitation along the western parts of the Pacific Ocean. And after reaching a point in the troposphere, the air diverges in opposite direction and one wing reaches the eastern coast of Pacific Ocean, leading to high pressure conditions in these areas. So because of high pressure conditions in areas and already existing trade winds which drag out the warm water from the eastern area, there is upwelling of cold water from below to fill this gap. So you have continuous upwelling of cold water from below. So under the usual normal condition, the eastern part of Pacific Ocean is cooler and the western part of Pacific Ocean is warmer. However, under certain time periods of the year, these conditions are reversed. So in El Nino phase, the normal conditions are reversed because of poorly developed trade winds around certain years. So because of poorly developed trade winds, the already piled up warm water in the western region moves back to its original position, leading to increase in temperature of the central as well as the eastern Pacific Ocean along with the western Pacific Ocean. So the entire central Pacific Ocean around the equator or around the tropical area experience warming up, okay, warming up of the surface water of the Pacific Ocean. So because the warm water is pushed back to its original position, so during this time period there is no upwelling, okay, no upwelling of cold water from below, and the entire surface of the Pacific Ocean from west to east experience the warm current moving back from the western part of the Pacific Ocean towards the eastern part. So because the eastern and central Pacific Ocean experience warming up of the sea surface water of the Pacific Ocean, the central and eastern part experience development of low pressure conditions because of accumulation of warm waters in these areas. Therefore, the central and eastern Pacific Ocean experience precipitation. However, the western Pacific Ocean experience less to no rainfall or dry conditions prevail in the Western Pacific Ocean because of the changes in the pressure conditions in the area as the impact of El Nino. Now usually the El Nino conditions are followed by the La Nina conditions. So under the La Nina conditions you have extensive cooling of the eastern and central Pacific Ocean due to more aggressively developed trade winds. So sometimes the trade winds are more intense, which pile up more than usual waters around the western Pacific Ocean or along the Asian coast. So under those circumstances, the neutral conditions which were prevailing earlier becomes extensively developed, and La Nina conditions are the extensive version of the normal neutral conditions which exist in the Pacific Ocean. And La Nina conditions generally follow the El Nino phase, followed by extensive cooling of the eastern Pacific Ocean. So lower than usual temperatures are found in the central as well as the eastern Pacific Ocean, whereas higher than usual temperature exists along the western coast of Pacific Ocean, because of which you have more extensively developed low pressure systems and more extensive rainfall and precipitation regime along the western areas. So extensive cyclonic activity is also witnessed in these areas during the La Nina conditions, and opposite to this you have very high pressure systems which prevail along the central and eastern Pacific Ocean. So you have more upwelling of cold waters from below because more and more water from the surface of the Pacific Ocean is pushed towards the west due to extensively developed trade winds. So as there is more gap which is left in the eastern Pacific Ocean, and to cover that gap there is more upwelling of cold waters from below, leading to drier than usual conditions in the area, cooler than usual conditions in the area. However, these conditions are also associated with better conditions for the development of fishes in the coastal area. So although drier conditions prevail in terms of existing atmospheric conditions in the area, however, it is good for the fishing industry. So the entire eastern and central part experience high pressure systems and cooling up of the equatorial Pacific Ocean waters. However, during the La Nina conditions, you have warmer than usual conditions which exist in the western Pacific Ocean. And you have extensively low development of pressure systems and high precipitation which is experienced along the Asian side. So these are the three phases of the ENSO cycle. Now you can see that apart from the existing north-south atmospheric circulation, the localized east-west ENSO circulation may also have profound impact not only on the weather and atmospheric conditions of the Pacific Ocean itself, but also on the climatic patterns and atmospheric systems along both of its adjoining areas, specifically in the tropical region. And it not only impacts the weather and atmospheric conditions, but it also impacts the ocean systems, because the ENSO cycle also impacts the upwelling which is experienced in the Pacific Ocean. So a regionally developed east-west circulation apart from the north-south general circulation may also impact the weather and climatic patterns around the globe. El Nino southern oscillations is the best example of how the oscillations of temperature conditions in the Pacific Ocean can have profound impact not only on the atmospheric systems but also on the oceanic systems. And sometimes the impact of these atmospheric regional circulations may also be experienced in far northern and southern extremities of the world also. So it has got a very profound impact on the ocean as well as the atmospheric system which prevail across the globe. The ENSO phenomena or El Nino Southern Oscillation phenomena is not just a regional phenomena now. Today it has evolved and it is described more as a climate change event or climate change phenomena, the impact of which can be felt even in the northern and southern extremities of the world also. Now let's just see quickly how ENSO impact the monsoon conditions. So as we know that under the ENSO we have three phases. We have the El Nino phase, which is the warmer phase of the central and eastern Pacific Ocean. Then we have the neutral phase, which have the usual conditions prevailing in Pacific Ocean with warmer conditions along the western side and cooler conditions along the eastern side of Pacific Ocean. And then you have the La Nina phase, which is kind of the extension of the neutral conditions, where the neutral conditions becomes more intensified with more warmer conditions along the western side and cooler than usual conditions along the eastern side. All the three phases of the ENSO cycle also affect the monsoons, which prevail in Southeast Asia and India specifically. As we know that El Nino is the warmer phase of the eastern and central Pacific Ocean. So during those conditions, you have cooler than usual conditions or high pressure conditions prevail along the Asian side, because of which you have less rainfall. So El Nino conditions in the central and eastern Pacific Ocean, where you have warming up of the central and eastern Pacific Ocean, are always associated with less rainfall along the western or Asian side and poorly developed trade winds. So poorly developed trade winds are no more dragging the water along the western side, because of which the low pressure systems which usually exist along the Asian side are not developed, and hence the weakening of trade winds is also associated with weakening of that low pressure system. Hence the weaker monsoons are always associated with the El Nino conditions. So weaker monsoons means lower than usual rainfall which is experienced in these areas and generally associated with the widespread drought conditions which prevail in the entire Southeast Asia, Asia and India specifically. So El Nino conditions are always associated with lesser rainfall and ill-developed monsoon conditions over the Southeast Asian region. Now let's come to the neutral phase. So as we know that during the neutral phase you have generally trade winds blowing from east to west. So you have usual low pressure conditions which lead to usual rainfall conditions. So during the neutral phase you will have the average development of monsoon conditions and usual rainfall is experienced in Indian subcontinent over the Southeast Asian region. Besides the neutral conditions, you also have La Nina phase, which is the cooler phase of the Pacific Ocean. The La Nina is nothing but the more extension of the neutral phase only, where you have extensively developed trade winds which pile up more warm waters along the western side. So you have more extensively developed low pressure conditions along the western side. So although it is a cold phase for the central and eastern Pacific Ocean, the western Pacific Ocean undergoes more extensive development of low pressure systems and more extensively developed rainfall regime. So you have greater than normal rainfall conditions which exist in areas which leads to very heavy rainfall along the western coast or Asian coast. During this time period, you have more extensively developed monsoon conditions over the Indian subcontinent also. However, prolonged La Nina conditions or very extensively developed La Nina conditions may also lead to severely heavy rainfall causing floods in various Southeast Asian regions. So higher than usual monsoon conditions also exist over India, sometimes leading to heavy rainfall and flooding conditions in the region also. So all the three phases of ENSO, as you can see, have different impact over the monsoon regime. So we will be covering this particular area more extensively when we will talk specifically about monsoons in the coming videos. But for now, you have to understand that during the El Nino phase, you have bad monsoon, drought-like conditions, you have poor monsoon, and during the La Nina conditions, Western Pacific Ocean, you have extensively developed low pressure systems which lead to heavy precipitation and unusually heavy rainfall during the monsoons can be observed over the Indian subcontinent. Now summarizing the video. The ENSO is the cycle of oscillating warm and cold sea surface temperature of the tropical, central and eastern Pacific Ocean. So the primary component is the oscillating temperature conditions, and this naturally occurring phenomena involves fluctuations in the temperature, specifically the sea surface temperature in the central and eastern Pacific Ocean, which is coupled with changes in the atmospheric conditions also of the particular areas. So this ENSO, El Nino Southern Oscillation, is actually a cycle of warm and cold temperatures. So it has different phases, while the El Nino is primarily associated with the warm conditions in the tropical Pacific Ocean and weakening of trade winds, bad monsoons across the tropical region and warming of central and eastern Pacific Ocean, while the La Nina event is associated with the intensification of trade winds, cooler conditions and increased intensity of rainfall in the tropical areas. In between these two phases, you have a neutral phase also, which marks the transition period between the El Nino and La Nina. But both these events have significant impact on the climatic patterns and weather conditions, specifically in the tropical areas. So with El Nino, you have weaker trade winds, you have bad monsoon, while La Nina events are associated with very heavy monsoon showers, sometimes even leading to flood conditions in the areas also. Over the years, scientific progress on the understanding and modeling of these extreme events has improved prediction skills, and it has also given the opportunity for the society to prepare better for these events, which may range from heavy rains, floods during the La Nina time period, and droughts and very dry conditions during the El Nino time period. So this was all about the El Nino and southern oscillations, Walker cell, and how the El Nino and La Nina conditions, ENSO conditions, impact the weather and climatic conditions, specifically in the tropical areas of the world. So this was all about it. Thank you so much.